Let us learn about templates in C++. An important feature of C++ is templates, which provide us a way to write generic and reusable code. When you define a template, you are creating a blueprint for a function or a class that can operate with different data types. However, the actual code for that function or class isn't generated until you specify the concrete data type to use with that template. Templates in C++ can be of two types. These are class templates and function templates. Let us first understand class templates. A class template is used to design generic classes. Here is the format of how to define a class template in C++. First we mention the keyword template, then inside the bracket we mention the keyword class followed by generic data type T. Then we define our class code as always. You can define a member function of a generic class inside the class or outside it. If you are defining the member function outside the class, then the format is like this. First we mention keyword template, then inside the bracket keyword class followed by generic data type T. Then to define the body of the member function, we write return type, class name, generic data type T inside bracket, scope resolution operator, name of the function, and we pass any arguments if required, and then we write the body of the function inside the curly braces. If your class template has multiple parameters, then mention those inside the bracket separated by comma as shown over here. In this program, we will learn how to perform addition of two integers and two floating point numbers using class templates. Let us begin by defining our template by typing the keyword template. Then let's type the bracket, then mention class and then generic data type as T. Here both our values will be of same data type, whether integers or float or double. Now we are going to define our class. Let's call this class as add. Inside this class we will be having private data members of data type T. Let's say that the name of the first member variable is num1 and similarly the name of the second member variable is num2. Then we will define our member functions. Let's say that the name of my first member function is void getValues and this function will be taking the input from the user for num1 and num2. Similarly, my second member function is void sum and this will be performing addition of the two variables. Next is to define the member function body. For that we need to once again type here template and then class T. Then we can proceed with defining our member functions. So first of all type the return type, then class name, then mention the generic data type as T, and after that put scope resolution operator, name of the first member function which is getValues. There are no parameters for this member function. Now we can type here /n, enter value of num1, and in the next line I will be getting the input from the user. Similarly cout /n, enter value of num2, and then in the next line we can type num2. Let us now define our second member function, but before that we once again have to add this line template class T. This line has to be repeated every time you are defining a member function of a class template or whenever you are creating a class template. So return type of the function is void, name of the class is add, then generic data type, scope resolution operator, name of the member function, no parameters are there. Inside the body of this member function I am simply going to print one line which says /n sum of, and then I want the value of num1 to be printed, and then I will mention here and next is to print the value of num2, then is equal to, and then I can simply add num1 with num2. So here the output will be printed like this. Suppose the value of num1 is 10 and num2 is 20. So output will be sum of 10 and 20 is equal to 10 plus 20 will give me 30, so is equal to 30. Next we define the main function. Let me just add some space. I am now going to create the object of class add. So I want to assign integer values for object 1. obj1 is the object of the class add, and now I will be displaying one message on the screen performing integer addition. In the next step I will be calling the first member function of this class, which is get values, using the object that I have just created, and similarly I will be calling the sum member function once I receive the values from the user. Here I will type return 0. Let's also perform floating point addition. So once again I will have to create object of this class, but this time with data type float. Let's call this object as 2. Let's copy paste these lines and add them over here. Let's make the changes. So this time we are performing floating point type addition, and then we will be calling get values using object 2 and sum using object 2 as well. Let's save this program and execute it. So here in the output you can see performing integer addition, and it is asking me to enter integer value. Let's say my first value is 12 and maybe the second value is 14. So sum of 12 and 14 is 26. Now we are performing floating point type addition. Let's say 2.45 and maybe 87.965. So here sum of 2.45 and 87.965 is 90.415. So this is how we can use class templates to perform integer or floating point addition. Let us suppose that instead of performing addition between two values of the same data type, we want to perform addition between two values of different data types, maybe an integer and a floating point value, or a floating point type value and a double. So in that case we can make a few changes to the program code. First of all, here we will be adding type T1 and class type T2. So this line means that we are going to work with two different data types, T1 and T2. I will be copying this code and pasting it everywhere where I have written template class T. So this code will be changed. In the next step, I will be making variable num1 to be of type T1 and variable num2 to be of type T2. Then moving ahead, here we will have to mention type T1 comma type T2, and similarly while defining the second member function also we will be specifying T1 comma T2. Okay, now last change that we have to make is here. Let's suppose that I want to perform an addition between an integer value and a floating point type value. So I will be adding one float data type over here. So T1 will be int and T2 will be float. And similarly, if I want to make addition between a float and a double, then I will have to specify here double as the second data type. So for the second object, T1 will be float and T2 will be double. Let's make one more change. So this becomes performing first addition and the second one becomes performing second addition. Let's now run the program. So this time for performing first addition, we will have to supply one integer value. Num1 will be an integer value and num2 will be a floating point type value, maybe 12.35. So the sum of 10 and 12.35 is 22.35. For the second addition, value of num1 will be a decimal point type number. It's a floating point type value. And similarly, the value of num2 will be a decimal point type value. So let's say this is the value, and here we can see the addition has been performed. So this is how we can use multiple parameters for class templates. Next is function templates. A function template is used to create a function that can operate with any data type. The format of defining a function template is shown over here. First we mention the keyword template, then inside the bracket we mention the keyword type name followed by generic data type T. Then we define our function body just like we have been doing it till now. We can also define a function template with multiple parameters. So inside the bracket, we specify all the type names with which we are defining our function template. Now in this part, we will be creating a program to find greatest of two values using function templates. Let us begin by defining the function template using keyword template. Then inside the bracket, we will be specifying type name as T. So T is the generic data type. In the next step, we will be defining the function. So return type is T. T is just like a placeholder for the data type or the return type of the function, because we don't know what data type to use right now. So it's just T, and name of the function will be max value. Then we will be defining two parameters of type T. The first parameter is X and the second parameter again of type T is Y. Inside the function body, we will be returning the bigger of the two values using a conditional operator. So here X greater than Y and then question mark. If X is bigger than Y, then return X, otherwise return Y. So this is how we can use conditional operator to find the bigger of the two values. In the next step, we will be defining the main function. Inside the main function, let us first declare two integer type variables num1 and num2 with values 12 and 15 respectively. Now we will be displaying the greatest of two values num1 and num2. So here I will be typing greatest between, and then I want to put value of num1 and num2, and here I will type is, and then I will be calling the function max value with values of num1 and num2. So num1 will be going in place of X and num2 will be going in place of Y, and this function will be finding out which value is greatest. And this is how we can find out the greatest between the two integer values. In the same way, we can check which value is bigger among two values of double data type. Let's say my first value is 3.57 and second value of double data type D2 is 3.587. Okay, once again I want to display this line greatest of two numbers, and here I will add one more /n, and here I will put D1 and here D2 and call this function with values of D1 and D2. Let us also use this function to check which character has higher ASCII code value. So here I will be defining character type C1, and let's say the value is A, and similarly C2 with value capital A. Both are written inside single quotation marks to indicate that these are character values. Once again, I will be copying this line of code and paste it and make one change over here. Instead of D1, I will type C1 and D2 becomes C2. Similarly, here also C1 and C2 will be used to call the function. Let's run this program. In the final output, when we are comparing two integer type values 12 and 15, the higher value is 15. When we are comparing two double data type values 3.57 and 3.587, then the second value is the greatest. In the last comparison, we have two character type values small a and capital A. In this case, their ASCII codes are compared. Small a has ASCII code 97 while capital A has ASCII code value 65, and that is why small a is bigger than capital A in the final output. Let us talk about benefits of templates. First is code reusability. We can write the function or class once and use it with any data type. In this way, templates make our code more flexible. Next benefit is type safety. The compiler checks that the data types used with the template are compatible. And third is performance. There is no additional processing required at runtime to handle templates. Thus, it helps to process our programs faster and more efficiently.